Hi everyone, welcome back to my channel. So today in this video we'll be learning about what is regression. So we already saw different types of supervised classification techniques. We saw the KNN, that is the K nearest neighbors. We saw the naive Bayes. We saw the decision trees. So there is one more classification algorithm that we have, that is SVM. So I currently don't start with SVM because we need to have certain concepts or some terms which are there from regression as well as linear and logistic regression that we need to use in SVM. So for that reason I just consider to begin with regression. So let's begin. So what basically regression is, or why we require regression and classification as in supervised techniques. So just consider, say in my locality today the temperature is around 33 degrees Celsius. Now after 1 hour it just rained, and if I want to predict, or if I want to say go outside and like for that dependency I just want to predict what would be the outside temperature is. So based on the previous condition I will just suggest what would be the temperature in next 3 hours or next 4 hours. So basically what I did is I have some input variable. Now I tried to predict the value of this input variable based upon the previous conditions or previous value data. So what regression basically does is, you have some input variable, say y, and you try to predict the value based upon the previous condition. So you already have some value which is happened before and you try to predict value of those. So that basically is regression. So what you do is just consider the scenario where you have this xy plane. So there are some like say points, data points scattered here and there. So just consider this as the temperature. So what I did is I basically predicted, say I just predicted the temperature that is 33 degrees Celsius. Now these are different temperature values which are here, say for example 27 degrees Celsius. Now this prediction would be the time that I would be going outside. So if in the morning the temperature was around 10 degrees Celsius, then later after it became like hot, what would be the temperature? So these are the various estimates of my temperature. So basically what I have is I just have a set of points or a set of values which are dispersed over this entire space. So what regression basically does is it just considers a mathematical function. So a mathematical formulation for fitting a curve over these values. So what it does is it necessarily finds a mathematical equation so that it will just try to fit a curve or some line on this, so that all these points well fits on this curve. Now say for example if your points are like this, or if your values are dispersed in this way, what you will have is a curve something like this. So this will have the equation y is equal to x square, or if your curve is something like this, then you will have the equation as y is equal to x cube. So something like this. So your points will be dispersed in such a way that you will have to fit a line, so passing through all these points so that it well describes this. So what the condition here is, you necessarily do the function approximation. So this is the term here, or you can call this as interpolation. Means you try to fit all the data points inside one particular curve and then you try to predict the value. Now say for instance I try to predict the value of this, and say the temperature I predicted was around 34 degrees Celsius. Now what I have is, I have a function that is I want to predict value of this, so I will consider a function as a. So this is my input variable for which the value changes. Now for each and every value of a, the value of y changes. So a is a dependent variable and y is our predictor variable or the target variable. Now say for example if I predicted with this function the temperature as 34 degrees Celsius, but then I checked my app, or in my weather app I just saw the temperature was slightly different, like it was 32.7 degrees Celsius. So there is some 0.3 error estimate there. So what my function would look probably would be like this. So what I did is I have my prediction here, and so this is the performance indicator. Or the error margin which I have. So I predicted for some value A and I got some prediction. Now that prediction was not 100% accurate. So for that I need to have some error estimate so that it compensates over there. So this is the function, how it is done. Now the main question is why we need to do the function approximation, or what is the need for you to do the function approximation. Say for example, you have this function. So in regression, when you just input into a model, so you have this regression function. So this regression function you will just input into the model and you try to predict some values. Now just consider the scenario if you don't have that much strong function, or if your function does not consist all of the points but only of a few of the points. So what you will get as an output, you will get a less predicted values, means your prediction power is not that strong. So what regression does is it have all the continuous values, means all the real numbers and all the integers. It deals with these kind of values. So whatever real valued inputs you have, you get a continuous range of series values. Now this can be, say for example, for the time series data, like you have particular time of the day, 10, 11, 12, 13 and 14. In this you have different values, like at 10 o'clock you had the temperature as 33, at 11 it increased to 34, then at 12 it increased to 36 and so on. So what you do is you just try to fit a curve, or you just try to pass a curve so that it best fits this equation. Now you understood why we require this function approximation, or what is the need for you to estimate this value function, that is y is equal to f of a. Now one question which comes to mind is which of the algorithms to use for this. Now there are n number of algorithms. You have the CNN, that is the convolutional neural networks. You can have the random forest, or you can go with AdaBoost, or you have something called as gradient boosting. So you can use any of these algorithms for regressing your data, but which algorithm and when to use this, so that becomes a quite challenging, or that becomes a complexity. But there is no specific algorithm when to use at what scenario. So it all depends upon what kind of problem you have, and basically your data which you have in your hand. How is your data? It's randomly distributed, or it's in a continuous time series manner. So based upon that you implement any of this algorithm. And one advice is that you try to predict your accuracy based on 3 of these algorithms. So it's always a best practice. So it can be said in the analogy like when you go to some particular place, and if you don't know that particular location, you probably ask 2 or 3 people so that you get into the right direction and not land into the wrong direction. Similar is the case with regression. You try to implement with 3 or 4 algorithms, then you try to predict the accuracy of this. So well, that was all regarding the concept of regression in machine learning. So hope you guys enjoyed this video and got educated from this video. Please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.